my name is Subhasis. Today we will be presenting about monitoring blockchain performance as part of our Hackathon 2018. Here is our team, Srijit, Durga and myself. Three of us contributed in the POC round. Let's start with a very powerful statement from Howard. They say very strongly, blockchain will do to the financial system what the internet did to the media. With this very powerful statement, let's move on to the problem statement. How do we monitor performance of blockchain application and infrastructure? Primarily from two persona. One is service provider. The first one, service provider of a blockchain application. When an application or service is hosted in blockchain environment, it needs a mechanism for determining the performance metrics of that blockchain-enabled application or service to adhere to the SLAs. From the other persona perspective, like as a blockchain infrastructure provider or blockchain-based computation, identifying infrastructure, network, performance issue with the blockchain processing system. Overall, missing end-to-end traceability for a transaction comprising of pure or hybrid blockchain-based smart contracts. I'll elaborate on this in the consecutive slide here. Primarily from the miner's perspective, we do have siloed or standalone monitoring. May not be the infrastructure. On the service provider side, we don't have any monitoring solution for smart contract-based services today. No single pane of glass for app, blockchain, and info metrics, and also no correlation among intra-blockchain and app performance metrics. There is a big problem here in terms of monitoring gap and SLA challenge. How? Let's say a typical transaction, okay? The transaction may comprise of services which are non-blockchain, or transaction may comprise of services which are like pure blockchain and non-blockchain or hybrid. Now, the first one is fine because we have some monitoring capability to monitor all these kind of services because they are not blockchain based. But in case of other transactions here, the highlighted ones in red, we have a challenge here because we don't have any monitoring capability for this pure or hybrid blockchain services. So basically there is a monitoring gap for that particular transaction, and because there is a monitoring gap, we cannot provide the SLA guarantee, right? There is a SLA challenge here. Now, how do we kind of address it? If we monitor apart from non-blockchain services, basically if we can monitor the pure blockchain or hybrid blockchain services, then for all kind of transactions, we kind of address that monitoring gap issue, and we also help in adhering to the SLA requirements for those transactions as well. This is how a blockchain transaction work. Once a transaction is requested, a block that represents the transaction is created. The block is sent to every node in the network. This is where the miner nodes get involved to validate the transaction, and in return, the node which is the fastest one to validate a transaction gets the reward for the proof of work or proof of authority. The block is added to the existing blockchain and the transaction is marked as complete. This is the architecture diagram of how we are trying to address, let's say, the ops personnel with respect to APM application. Here they access the APM agent for blockchain to capture the performance metrics of smart contracts and also infrastructure and blockchain metrics via this gate interface that is there in the blockchain network. I'll talk about this gate in the consecutive slide. Now, once those metrics are captured, they are represented in APM directly or also in future in DUI and for visualization and metrics correlation. Now, blockchain-based service provider, they develop Solidity-based smart contract application and deploy those applications in terms of services in the blockchain network. Now, end user, when they will be making some transaction using these services, the blockchain miners will get involved to mine those transactions, and in return they will earn the ether. So this is the high-level architecture diagram, and basically along with any kind of application that we monitor in APM space, we also have put a new block here, smart contract-based services, which are lying in Ethereum or Hyperledger or any other private or hybrid blockchain network. These are some of the very important pure blockchain metrics like total number of blocks, block time, difficulty, gas limit, average block time, average network hash rate, etc. With that, let's talk about the component from open source or CA that we have reused. From open source perspective, we have used Ethereum, Solidity, Ethereum J, Web3j, Geth, Elasticsearch, and Kibana. From CU component side, we have used CA APM agent for monitoring performance and monitoring infrastructure. The work that we have done is created a private blockchain network using Ethereum. We have developed few smart contract applications. Two of them are, one of them is fund transfer, and the other one is a general purpose calculator service in Ethereum network. And then we have wrapped that smart contract using Web3j and Ethereum J because we don't have a monitoring solution today for Solidity language, so we have to wrap it in Java. And then APM agent for monitoring app performance and APM agent for monitoring blockchain infrastructure that also includes getting the blockchain metrics using Geth from blockchain network. And the final one is Kibana dashboard for the visualization and manual way of correlating the matrices. Okay, let's quickly go to the demo. Here, as soon as here we have created a small smart contract application, the calculator service as I talked, and we can perform the transaction, the operations that is exposed via the smart contract here. Okay, so the moment I'm clicking on this add subtract, as you can map here add and subtract here, those operations are getting those transactions are getting posted in the blockchain network here. Okay, and for now I have kind of kept the minor stop so that I can show you one particular use case. Now before that, you can also see the blockchain metrics that is coming from my private blockchain network here, and let's go to the APM map view. Here you can see the infrastructure metrics being shown here for the blockchain node here. The moment I expand, you can see it expands to blockchain Geth server. And from here, I have two kind of metrics. One is agent. This kind of shows me the infrastructure metric, and blockchain node shows the blockchain specific metric. This is in progress. Let's quickly go through the web view. And first, let me cover the application performance metrics. So typical blame point tracer metrics here, you can see under blockchain node fund transfer application, we have 5 metrics here: average response time, concurrent invocation responses per interval, stall count, etc. So you can see there are some data that is coming from the fund transfer application that we have deployed in the blockchain network. Likewise, you can go to the infrastructure node here, and you can see these generic blockchain metrics here, block size. I'll just change the timeline here so that we can monitor the graphs for those particular pure blockchain metrics here. Okay, these all are pure blockchain metrics. Along with this, you will also have infrastructure, typical infrastructure metric like you get today, irrespective of whether it is blockchain or not. Okay, now the final part of the presentation is visualization. Now you have already seen I have created some transactions here, and I have kept the minus stopped. Basically, the use case is here you have many pending transactions, average gas needed, okay, average difficulty, and here we have so many other metrics. Now some of the metrics are pure blockchain metrics, like the one, let's say, pending transaction. So at this point you see the pending transaction count kind of shooted up. It was very high. Basically these many transactions are pending because you may have less number of miners, so the miners will be validating the transactions. But at the same time you see this is an APM matrix where it shows the application response time also kind of shoots up because the miners are busy with so many transactions here, and we have too many pending transactions, and the average responses per interval is also coming down because they are not able to respond to those transactions pretty quick. So that's pretty much it.